Okay, so for our first problem, 10 to the 20 electrons, that's a lot of electrons by the way, struck the ground as lightning from a cloud. It took 2 milliseconds, ms, for all the electrons to pass. What is the current of the lightning strike? So let's try to understand what that means. So basically what's happening is there's a lightning strike, right? Like lightning hit the ground from a cloud. And all the charges in that lightning is 10 to the 20 electrons. And pag agi gani sa 10 to the 20 electrons, it only took 2 milliseconds. So let's try to draw that. So notice this cloud, that's where the electrons came from. So they're saying that all the electrons, it went down to the ground in 2 milliseconds. So this is a current, right? Because remember, electrons are flowing. So now we have these, solve for the current of the lightning strike. So what is our given? We're given charge, right? Our charge is 10 to the 20 electrons. Remember that electrons is still a charge because, those are elementary charges. And don't forget the E minus or the minus E because it's an electron, by the way, which is negative. And then the time it took is 2 milliseconds. Sorry, that's not supposed to be 2 minutes. My apologies for that. Hold on. 2 milliseconds. And the current is what? What is the current? So here's the solution. First, before we start to solve the current, let's try to convert these values first. So we've got 10 to the 20 electrons. Yes, it's an electron, so we want the charges to be in coulombs, right? So let's convert it. There's electrons. So in one electron, sorry, there's supposed to be a minus over there. In one electron, there are negative 1.602, or just negative 1.6 in this scenario. Negative 1.6 times 10 to the power of negative 19 coulombs. So convert that, and you'll end up with negative 16 coulombs. And now for the time. So we got 2 milliseconds, right? And that says milli, so 1,000. So 1,000 below 1 second, which is 1 times 10 to the power of negative 3 seconds. Convert that, and you'll end up with 2 times 10 to the power of negative 3 seconds. Now that we have both of these values now prepped up and ready, we can now solve for current. So current is the change in charge. Oh yeah, by the way, yeah, it's supposed to be Q because charged. I don't know why the hell I put C there, but ignore that mistake. Anyway, charge over time. Negative 16 coulombs over 2 times 10 to the power of negative 3 seconds. Put that in your calculator and you'll end up with negative 8,000 coulombs per second. That's a lot of electricity, by the way. Like, that current is very high. And the unit for current is amperes, or A. But this is in the thousands, so it's kiloampere. Negative 8 kiloampere. So our answer is, the overall current of the lightning strike was negative 8 kiloamperes.